Welcome, aspiring network engineers, to today's exciting lesson on Domain Name System, DNS. In this session, we'll delve into the fascinating world of DNS, which plays a vital role in translating human-readable domain names into machine-understandable IP addresses. Understanding DNS is crucial for the CCNA 200, 301 exam and for real-world networking scenarios. DNS stands for Domain Name System. It serves as the Internet's address book, converting domain names, like www.example.com, into their corresponding IP addresses, like 192.0.2.1. Imagine DNS as a massive distributed database where domain names are mapped to IP addresses, allowing us to access websites, send emails, and perform other Internet activities using friendly domain names instead of memorizing numerical IP addresses. DNS, Domain Name System, is a crucial part of the Internet, and it involves various components working together to translate human-readable domain names into IP addresses, enabling communication between devices. At the forefront of the DNS components is the DNS resolver, a client-side element responsible for making DNS queries to resolve domain names. When you enter a URL into your browser, your computer's DNS resolver springs into action, seeking the corresponding IP address. This role can be played by any device connecting to the Internet, such as computers or smartphones. On the other side, we have the DNS server, a server-side component that stores DNS records and responds to DNS queries. There are two main types of DNS servers: the authoritative DNS servers, which hold the actual DNS records for specific domains, providing the definitive answers when queried about a domain, and the recursive DNS servers, which aid DNS resolvers by fetching DNS records on their behalf. If a recursive server doesn't have the answer cached, it will tirelessly traverse the DNS hierarchy until it locates the authoritative DNS server for the domain in question. Together, these DNS components ensure smooth and efficient communication on the Internet, allowing users to access websites and services with ease. Let's dive into how DNS works in a step-by-step process. Step 1. DNS query initiation. When you enter a domain name in your browser, for example www.example.com, your computer's DNS resolver initiates a DNS query. The resolver first checks its cache to see if it already has the IP address for the domain. Step 2. Recursive query. If the DNS resolver doesn't have the IP address, it sends a recursive query to a nearby recursive DNS server provided by your ISP, Internet Service Provider. This server may have the answer cached, or it will begin the iterative process of finding the answer. Step 3. Iterative query. The recursive DNS server sends an iterative query to the root DNS server, asking for the authoritative DNS server responsible for the top-level domain, for example.com. Step 4. Authoritative DNS server. The root DNS server responds to the recursive server with the IP address of the TLD's authoritative DNS server for the domain, for example, ns1.example.com. Step 5. Further resolution. The recursive DNS server then sends an iterative query to the authoritative DNS server specified by the root server, asking for the IP address of the requested domain, for example, www.example.com. Step 6. DNS resolution. The authoritative DNS server responds to the recursive server with the IP address of the requested domain, for example, 192.0.2.1. Step 7. Response to resolver. The recursive DNS server caches the response and sends the IP address back to your computer's DNS resolver. Step 8. Final resolution. Finally, your computer's DNS resolver stores the IP address in its cache and uses it to connect to the desired website. The next time you visit the same website, your resolver can quickly provide the IP address from its cache, reducing the query time. DNS servers store various types of resource records, RRs, to hold different types of information. Here are some essential DNS record types. A record, address record. This record maps a domain name to an IPv4 address. Here's an example. Record, IPv6 address record. This record maps a domain name to an IPv6 address. Here's an example. Canonical name record. This record creates an alias for an existing domain name. Here's an example. Mail exchange record. This record specifies the mail server responsible for receiving emails on behalf of a domain. Here's an example. NS record. Name server record. This record indicates the authoritative DNS servers for a domain. Here's an example. In some instances, you may encounter DNS, domain name system issues, that can disrupt your internet connectivity or access to certain websites. To troubleshoot and resolve these problems, here are some common steps you can take. 1. Check DNS configuration. The first step is to verify that your device's DNS settings are correctly configured. On Windows, you can use the ipconfig command in the command prompt to view and modify DNS settings. Ensure that the DNS server addresses are accurate and match your network's requirements. 2. Flush DNS cache. Sometimes your DNS resolver's cache may hold outdated information, leading to incorrect domain resolution. To fetch fresh DNS details, you can flush the DNS cache. On Windows, execute the ipconfig/flushdns command in the command prompt. 3. Ping the domain. To check if the domain name is resolving to the correct IP address, you can use the ping command in the command prompt. For example, typing pingexample.com will attempt to ping the domain example.com and display the associated IP address if successful. 4. Check firewall settings. Firewalls can sometimes interfere with DNS queries, resulting in resolution problems. Ensure that your firewall isn't blocking DNS requests. Review your firewall settings and make any necessary adjustments to allow DNS traffic. By following these troubleshooting steps, you can often identify and resolve common DNS issues, restoring smooth internet connectivity and efficient domain resolution. We hope this video helped you on your journey towards becoming a cybersecurity expert. Remember to subscribe to our channel and turn on notifications so you never miss out on our latest content. And if you found our videos helpful, please give us a thumbs up and share them with your friends and colleagues. Don't forget to check out the links and description for our Anki flashcards and to donate to St. Jude Children's Research Hospital. Your support can make a real difference in the lives of those in need. Thanks again for watching, and we'll see you in the next video.